Hello students, today we are going to discuss about the 9th standard mathematics first chapter, number systems. Directly going into the chapter, first we should understand the meaning of the chapter name. Name is number system. Let us understand the meaning of number and number system. Number is the arithmetical value representing a particular quantity and used for counting and making calculation. Number system is a mathematical notation for representing numbers of a given set by using digits in a consistent manner. In a number system, there are different types of numbers are there. And the first one is natural numbers. Natural numbers starts from 1 and continues up to infinity. 1, 2, 3, 4 up to infinity. And natural numbers are denoted by capital N. Next type of numbers is whole numbers. Whole numbers starts from 0 and consists of natural number. Means 0, 1, 2, 3 up to infinity. These numbers are denoted by W. Next is integers. Whole numbers along with negative values of natural numbers are called integers. Whole numbers means 0, 1, 2, 3 along with negative values of natural numbers means -1, -2, -3. On either side it is continuing up to infinity. These integers are denoted by letter Z. Next type of numbers is rational numbers. Rational numbers are written in the form of P by Q. In P by Q, denominator Q should not be 0 and P and Q are integers. For example, 2 by 3 minus 4 by 7. These are all the few examples for rational numbers. These rational numbers are denoted by the letter Q. Next is irrational numbers. The numbers which cannot be written in the form of P by Q are called irrational numbers. For example, pi, square root 3, square root 7, etc. Real numbers. The collection of both rational numbers and irrational numbers are called real numbers. For example, 1 by 2, minus square root 3, pi, these are all come under the group of real numbers. These real numbers are denoted by capital R. Next come to the prime numbers. Prime numbers having only two factors, those are 1 and the number itself. If I consider the number 2, it is having the factor 1 and 2. If I consider 5, this 5 having the factors 1 and 5. Composite numbers. These numbers having the more than 2 factors. For example, I will consider 8. 8 is having the factors 1, 2, 4, 8. More than 2 factors are present in 8. Along with these numbers, there are other numbers also. Odd numbers, example 1, 3, 5, 7, etc. Even numbers 2, 4, 6, 8, etc. If I consider the positive numbers +1, +2, +3, we cannot, if we are not writing plus sign in front of number also, we can consider that number is a positive number. In the case of negative number, we need to mention negative sign in front of a number. For example, -1, -2, -. Next, come to the rational number. One more point I want to add here. If we write 2, 2 is considered as a rational number because denominator is not there. Denominator is not there means it's understood 1 is there in the denominator. If we write 7, 7 is also a rational number. It can be written in the form of P by Q, means 7 by 1. This is about the different types of numbers in a number system. Next is representation of a numbers on the number line. Under that, first I will consider whole number. You are already knowing whole number means it starts from 0 and continues up to infinity. Look at the diagram. On the line, I started from 0. Later, I written 1, 2, 3. At the last, at the end of the line, arrow mark is there. Arrow mark indicates the line is continuing up to infinite. Next is the integer. As we are already knowing, integer consists of positive and negative numbers along with 0. On the number line, middle we should mention 0. Right side we have to write positive number. Left side we have to write negative number. How we have to write positive number means 1, 2, 3. After 0 only you should start from 1. Left side also, after 0, before 0, you should start from -1. Later on it continues -2, -3, and in the case of integer, on both sides you should mention the arrow. It indicates it is continuing up to infinite. Next, come to the rational numbers. In the same way as we written for integer, we have to write here also. Along with writing 0, 1, 2, 3, we have to write the number of the form -1 by 2, 1 by 2, 1, 1 by 3, like that. P by Q form number should be written in the on the number line. Next is the real number. You are already knowing real number means it's a collection of rational number and irrational number. On the line 1 by 2, square root 2, 0, 1, 2, 3, all combinations of a number should be written on the line. This is about the number line representation. This is the diagram. This indicates the relationship between different types of a number. I written natural number in the middle because natural number starts from 1 and continues up to infinite. Next type of a number comes, that is whole number, because you are already knowing the definition. Whole number consists of natural number along with 0. So, whole number completely consists of natural number plus one more 0 also present in the case of whole number. So, I will include one sentence here. You have to understand that sentence. Every natural number is a whole number. That point we need to understand here. But converse is not true. Every whole number is not a natural number because in whole number 0 is there, but 0 is not present in a natural number. So here you need to understand every natural number is a whole number, but every whole number is not a natural number. Next, come to the next integer. We can say the definition. Every natural number is an integer, otherwise every whole number is an integer, because in a whole number it consists of 0 and 1, 2, 3 positive numbers is there. If we consider the negative numbers -1, 2, 3, it will give you the integer. Here also the statements every natural number is an integer, every whole number is an integer is true. It's converse. Every integer is not a whole number. That is not true in this case. Next is about the rational number. Look at the diagram. You can answer now easily. Every natural number is a rational number. Every whole number is a rational number. Every integer is a rational number. But converse is not true. And from the diagram, it is clearly understanding rational number plus irrational number is equal to real number. This is the diagram. If you understand this diagram, you can answer for many true or false questions. Now, let us discuss about one example problem based on that diagram. The question here is, state whether the following statements are true or false. Give reason for your answer. The first question here is, every natural number is a whole number. By looking at the diagram, you can answer easily. Look at the diagram. Every natural number is a whole number. Yes, inside the whole number, all natural number are there. One more zero if you consider, then it become whole number. That's what the first statement is true. Next, come to the second statement. Every integer is a whole number. Look at the diagram. We can say every whole number is an integer. But we cannot say every integer is a whole number. That's what the second statement is false. For that you need to give reason. What is the reason we can give? I'll consider one negative number, minus 2. Minus 2 is an integer, but minus 2 is not a whole number. That is the reason you can give for statement number 2. Next is the third statement. Every rational number is a whole number. Look at the diagram. Whether all rational number is a whole number? No, that is false. Only every whole number is a rational number. For that also you have to give reason. I will consider one example. 4 by 7. It is of the form P by Q. So we can consider it as a rational number. But 4 by 7 is not a whole number. Next statement is, every whole number is a natural number. Look at this diagram. No, it is false. Every natural number is a whole number, but every whole number is not a natural number. What is the reason we can give means? 0. 0 is a whole number, but 0 is not a natural number. Next statement. Every integer is a rational number. Look at the diagram now also. All integers are a rational number. Yes, it is true. Next, last statement here is, every rational number is an integer. Look at the diagram now. Every rational number, is it integer? No, it's false. You can give one more example. Minus 7 by 8. If I consider, it is a rational number. But does integer values are having the denominator other than 1? No. We cannot consider that number is an integer. That statement is false. You can give the example also. This is about the first example of our first chapter. Next, as you have understood all the concept about different types of numbers, we shall move on to the exercise problem itself. What is the first exercise problem? Look at the question. Is 0 a rational number? Yes, you are already knowing. 0 by 1 we can consider. 0 by 1 we can consider. Rational number means it should be of the form P by Q. Hence, 0 is a rational number. You should write the sentence as, yes, 0 is a rational number. Can you write it in the form of P by Q? You just write it like this. 0 by 1, 0 by 2, 0 by 3. Like this, you just write. Next, in this case, where P and Q are integers, 1, 2, 3 all are what? Integers. Next you can tell q should not be 0. Yes, in the denominator q is not 0. So what is the answer you should write for this question is S 0 a rational number. We can write in the form of p by q as 0 by 1, 0 by 2, 0 by 3. This is about the answer of first question. Next, look at the second question. Find 6 rational numbers between 3 and 4. How many rational numbers they are asking? 6 rational numbers. So that you have to take 6 plus 1 is equal to 7. Between which are the numbers 3 and 4? Take down the number 3. Here you write down the number 4. You are knowing in the numbers, denominator nothing is there means what is there? Denominator 1 is there. After adding with 6 plus 1, how much you got? 7. Just multiply the 7 for both numerator and denominator for both the numbers. Is equals to find out the values. What you are going to get? 3 sevens are 21, 1 sevens are 7, 4 sevens are 28, 1 sevens are 7. 3 by 1 is equivalent to 21 by 7. 4 by 1 is equivalent to 28 by 7. And you have to make sure one more point. In these two numbers, whether denominators are same or not. Look at this, two numbers, two answers. Yes, it is same. Both the denominators are 7. Now, you can write the numbers between these two. After 21 by 7, what is the next number? Yes, of course, it is 22 by 7. Next it is 23 by 7. After that, 24 by 7, 25 by 7, 26 by 7, 27 by 7. Look at the numbers. Whether you got between only? Yes, it starts from 21. The next number only 22. Here the number 28 is yes, before only 27 you are going to get. Then you got how many numbers? 6 numbers between 3 and 4. I hope you have understood the problem. In the same way only, we have to solve the next third problem. What is the third problem? Look at the question then. Find 5 rational numbers between 3 by 5 and 4 by 5. 5 rational numbers means I told already you have to do 5 plus 1. Okay. Between which are the numbers 3 by 5 and 4 by 5. Write down here 2 numbers. Procedure is same as previous problem. What you should do next? Take this 6, multiply to both numerator and denominator for both the numbers. Okay, 6 3s are 18, 6 5s are 30, again 6 4s are 24, 6 5s are 30. Between these, which are the numbers you are going to get? Tell me now. 18 by 30 means, of course, it is 19 by 30. Next is 20 by 30. Next number is 21 by 30. Next is 22 by 30. Next is 23 by 30. 24 by 30 we can't take because the last number is 24 by 30. So, how many numbers you got? You look at this. 5 is, they are asking in the question 5 rational numbers only. So, which are all the 5 rational numbers between 3 by 5 and 4 by 5? It is 19 by 30, 20 by 30, 21 by 30, 22 by 30, 23 by 30. This is the same procedure we have to apply for rational numbers also. we have to apply for the integers like 3 and 4, 5 and 7 also. Now I take up the next problem, fourth one, that is state whether the following statements are true or false. Give reason for your answer. Same question we discussed in the previous slide in the example one. I just added these question also. Let's recap those points now. What is the first question given? Before that I'll just read the diagram to understand clearly. First, which numbers comes? I write the symbols now, easy, fast. Natural number, later whole number is there. After that, integers, later will be the rational numbers. Okay. Next is, look at the first question. Every natural number is a whole number. Look at this. You can easily understand now. Yes, every natural number is a whole number. The first question answer is true. Second question. Every integer is a whole number. Look at it all. This is the integer. Whether every integer is a whole number? No. You have to write the answer false. For that you need to mention the reason also. What is the reason you can give means? Integer means it consists of negative number. So you take minus 5. Minus 5 is an integer. But minus 5 is not a whole number. Third one question. Every rational number is a whole number. Is it true? Look at the diagram. Here is rational number is there. Here is a whole number is there. Rational number means the number is of the form p by q. Whole number means nothing but we don't write in the denominator. All the values, denominator value is 1 only. We should not write other number like 2, 3 and all in the denominator. So this statement is false. If you are given some reason for that question, means you take any number. I will consider the number 12 by 40. 12 by 40 is of the form p by q. It is a rational number, but it is not a whole number. This is about the fourth problem of exercise 1.1. Next is irrational number topic. You are already knowing the irrational number. Irrational number means the numbers which cannot be written in the form of p by q, numerator and also denominator form. I repeat, irrational number means the numbers which cannot be written in the form of a p by q. For example, pi, root 3, root 2, root 7. These are all the irrational numbers. After finding the answer cannot be written in the form of p by. Based on this irrational number simple concept, we are having three problems in the exercise 1.2. We discuss two problems in today's class, remaining one more problem in the next class. Okay. First question here is, state whether the following statements are true or false. Just like previous problem. What is the first question? Every irrational number is a real number. They are asking here knowing this is the rational number. Next one more what comes? Irrational number. These two together is the real number you are going to get. What is the question they are telling? Every irrational number is a real number. Yes, real number is a combination of rational number and irrational number means yes, the statement is true. For example, if you are taking root 2 means root 2 is a irrational number and obviously it is a real number. Next is the second question. Every point on the number line is of the form square root m, where m is a natural number. This statement is false because if we consider the number line here, we can write infinite number between root 2 and root 3. For example, consider some way. Root 2 is there, here root 3 is there. In between root 2 and root 3 also, infinitely many numbers are there. For example, square root of 2.1, square root of 2.2 like that. But if I write square root of 2.1 means 2.1 is not a whole number. 2.1 is not a natural number. They are asking one condition. What is that? Square root m, and also m is what? It is a natural number. If I write square root of 2.1, whether 2.1 is a natural number? No. So, this answer is, this statement is false. What is the reason you are going to write here is, there are infinite numbers between the square root 2 and square root 3 that cannot be represented as square root m, because m is being, it should be natural number. Third statement, every real number is an irrational number. Is it true? Every real number can be a rational number, because rational number and irrational number, those two combination is called real number. We cannot say all real numbers are irrational number. Every rational number can be a rational number also. So you should write the statement answer like this: false, because real number can be a irrational number. Next problem is, are the square roots of all positive integer irrational? For example, I will consider the question square root 4. You have already studied the square root chapter in the 8th standard. The value of the square root 4 is 2. Whether 2 is a rational number? No. 2 is a rational number. So, are the square roots of all positive integers are irrational? No. Because square root 4 value is what? 2. This is which number? Rational number. This is about the two problems on the irrational numbers. We will discuss in the next class about the third problem, that is locating the irrational numbers on the number line. Okay.